So once again, thank you everyone for joining us today for our 7th edition of Planetarium Online. My name is Andrew Bundes. I am one of the planetarium educators at the Liberty Science Center. And normally I'd be talking with you from the largest planetarium in the Western Hemisphere, the Jennifer Chalsty Planetarium. But today I am talking to you from my living room in my apartment. And today we're going to be talking all about Pluto. So talking about why Pluto is no longer considered a planet, talking a bit about why Pluto is still one of the most interesting places in our solar system, and a bit about why Pluto was called a planet to begin with in the first place. Before we do begin with all of that, though, just a few very quick things. If you have questions during the show today, you can write them into the comments section. I'll be trying to keep my eyes on them and answer as many as I can during the show. I'll also be hanging out after the show to answer more questions that you may have about Pluto or the solar system or really anything out there. We also do have my colleague Mike, who you may have seen give a little talk yesterday about the supermoon. He'll be in the comments section answering some of your questions as well. But I also did want to let you know about something else happening a little bit later on today at 6 o'clock p.m. today. Right here on our Facebook live stream, we are hosting a trivia game aimed at adults. That is today at 6 o'clock p.m. And then tomorrow morning at 11:30, we are hosting another trivia game. This one is going to be aimed more at families and kids. So we do hope to see you joining us for the rest of our Facebook live streams. We are broadcasting something every single day, Monday through Friday. So we do hope to see you for as many of these as you can. So with all that out of the way, let's go ahead and get started with our show all about Pluto. To begin with, let's look at our solar system as we know it today. So today, astronomers identify 8 planets in our solar system. Lots of other stuff too. There's things like the sun, and there's asteroids, and there's comets, and lots of other stuff out there. But when I was growing up in elementary school, and I'm sure this is the case for many of you viewing this, I was taught that Pluto was the 9th planet in the solar system. That's what I was taught when I was in elementary school. Now, back in 2006, that changed, right? Pluto was changed from being called a planet to today being called a dwarf planet. And so many of you watching this, I'm sure, have grown up always being taught that we had 8 planets and that Pluto was a dwarf planet. Now, why exactly did that decision happen? Well, it's probably the question I get the most often in my career as someone who loves to talk about space. To get one thing out of the way really, really quickly, Pluto still exists. Pluto is still out there in the outer edges of the solar system. It's still there, the same as it's always been. It hasn't been blown up or thrown out of the solar system or anything crazy like that. Pluto still exists. It's still out there at the edge of the solar system. So why in the world did it go from being called a planet for decades to now being called a dwarf planet? Well, to answer that question, we're going to actually start at the beginning of our understanding of Pluto. This is our understanding of the solar system as it would have looked back in the early 1900s, before Pluto was discovered. Back then, we knew about 8 planets in the solar system. We knew about the sun, but we began to find a few other things. In this part of the solar system, between Mars right here and Jupiter right here, we began to find more objects in what we today call the asteroid belt. The first of them is an asteroid, and today called a dwarf planet, by the name of Ceres. In addition to Ceres, we began to find other asteroids. Today, we found tens of thousands of asteroids in this part of the solar system. But in the early 1900s, over 100 years ago, we were just beginning to find more of these objects. The largest of them is Ceres, which I mentioned today we identify as a dwarf planet. But when it was discovered, we quickly realized that Ceres was too small to be called a planet. So most astronomers immediately were able to identify Ceres is not a planet. It's too small. We're going to call it an asteroid. But there were a lot of astronomers and a lot of mathematicians who were studying the orbits of our planets. And by looking at the orbits of the two outermost planets, that would be Uranus way up here and Neptune way out here, by studying their orbits very closely, we were able to predict that there was something else out there, outside the orbit of Neptune, something way out there, another planet that we predicted to exist. So astronomers in the early 1900s and the late 1800s immediately began to search for this mysterious ninth planet. Mathematicians predicted to exist out there. So astronomers all over the world began to search all throughout space to try and find this ninth planet. And one of the observatories and one of the telescopes that was very early on in this search is located in Flagstaff, Arizona, a little place called the Lowell Observatory. Lowell Observatory, we're going to fly down very close to it here and check it out, was one of the, and in fact, was the telescope used to find Pluto. Now, it was built in the late 1800s, in the 1880s, by a man named Percival Lowell, who was fascinated with the idea of finding a ninth planet. You can see him here looking through the telescope. Thankfully, astronomers don't need to actually look through telescopes with our eyes anymore. We use computers for that these days. But in Lowell's day, he had to sit in his chair and look through the telescope with his eyes and make drawings of what he saw. Now, I want to point out just how cool this chair contraption is that he's sitting on. So he's sitting in this chair. It's actually hooked up to like a chain and a pulley system. You can actually move this chair up and down so that when you move the telescope, you can still look through it. It's really cool. Now, Lowell built this observatory and this telescope, but he was not the one to find Pluto. The person who found Pluto was a gentleman by the name of Clyde Tombaugh. He was hired to work at the observatory in 1929. In 1929, he was hired to look for Pluto, to look for this mysterious ninth planet that we predicted to exist somewhere out in the outer reaches of the solar system. So his job was to take pictures of the same part of the sky on different days and look for a planet. So what was he looking for? How do we actually find a planet? What was he trying to find? So we're going to actually look at some planets that our eyes can see to just talk about what Clyde Tombaugh was a bit about what he was actually looking for. So actually, when we're looking for a planet, what we're really looking for is something to be moving. Right? We're looking for something to be moving across the sky. Because planets move very quickly as they go in their orbits throughout our solar system. So he was looking for something to be moving. Now, in doing this, he had to take pictures of the same part of the sky on different days and compare them to each other, looking for something to be moving. So we're going to do that exact same thing here. I'm going to pull up the two pictures that Clyde Tombaugh used to find Pluto, and we're going to look for something to be moving in them. So this right here is the same two images that Clyde Tombaugh used way back in 1930 to find Pluto. They were pictures taken on 2 different days. So look at this, at these 2 pictures and see if you can notice something moving in them. So look around through this and see if you can identify something moving in these pictures. And I promise Pluto is there. I promise Pluto's there. I'll give everyone a moment. And if you think you found Pluto, again, we're looking for something that has moved. So almost everything in this picture, in these 2 pictures, is staying still. Most of those things are stars. But one thing in here is moving, and that is Pluto. So I'll give everyone just a few more moments here to see if you can spot Pluto. It's a really hard thing to do, and this is what Clyde Tombaugh did for about a year. he spent that time searching through picture after picture after picture, looking for something to be moving. And I'm going to now draw a little red circle around where Pluto actually is in these pictures. And there is Pluto, that little speck of light that moves from the left to the right, left to right, left to right. That is Pluto. By finding that little speck of light, Clyde Tombaugh had found Pluto, which is really, really amazing to think about, right? He worked for over a year taking pictures and comparing them. And we now, in modern times, have it pretty easy when we're looking for planets and looking for moving things in space, because we can make little animations, little movies like the one that we are seeing here. For Clyde Tombaugh, he didn't have computers back in the 1930s to help him out. So what he used to compare these two pictures is this device right here. This is known as a blink comparator. The blink comparator. This is what he used to find Pluto. So he would put one picture in the left of this big device, another picture in the right. He would look through this eyepiece right here. You look through this little eyepiece right here and look at one image and then the other one, and then back and forth, just like what we were doing right there, looking for that little tiny dot to be moving. And he found Pluto, right? So in 1930, he found Pluto. He immediately let every astronomer all around the world know that he had found the 9th planet. Everyone was super excited about this, right? We've got a 9th planet. He predicted Pluto to be a lot more massive than it actually is. And the reason why Pluto was originally called a planet is because we thought it was really big. So when it was discovered in 1930, here's Pluto, the Earth, we thought that Pluto was about twice the size of the Earth. So in 1930, we thought Pluto was twice the size of our own Earth. Big enough to be a planet, right? Then a year later, studying it more, found out that Pluto was actually only the size of the Earth. Which is not a problem, still big enough to be a planet. But then we kept on studying Pluto and learning more and more and more about it. By the 1950s, we thought Pluto was about half the size of the Earth, which is still fine, enough to be a planet, no worries there. Mars is half the size of the Earth and it's a planet. Then by the 1970s, we thought Pluto was about a quarter the size of the Earth. And as we continue to study Pluto, we learned more and more and more that Pluto was actually pretty small. By the 1990s, and then in the early 2000s, we had learned that Pluto was only about 1/6 the size of the Earth. Pluto is smaller than the United States. Pluto would fit right on top of the United States, it would fit right on top of Australia. So had we had known originally how small Pluto was, there's a good chance we never would have called it a planet in the first place. So as we learn more about Pluto, we begin to rethink whether or not it should be a planet. But as of the early 2000s, people still, okay, Pluto's still a planet, right? We named it a planet, we're not just going to take it away. Well, at the same time that we are learning more about Pluto, we're also learning more about the rest of the solar system, right? So as we're learning more about Pluto, we're learning more about everything else. We had already discovered a series here in the asteroid belt. But on top of that, in 2004, we found Eris. It lives out in the same part of the solar system as Pluto. Then later in 2004, early 2005, we found something else known as Haumea. And then in 2005, we found something else called Makemake. And those of you who have heard of these objects before, Ceres, Haumea, Eris, Makemake, we know them today as the dwarf planets. So as we're finding all these other objects, we were also finding more things in this big group of objects here called the Kuiper Belt. So the Kuiper Belt is made up of a lot of small pieces of ice and rock. They're like the smallest ones we found are maybe 5 miles across. The biggest ones are a few hundred miles across. So we kept on finding more of these things. And so we're left to think, how much else is out there in the solar system that we haven't found yet? We had already found 4 things that we were ready to name as dwarf planets: Ceres, Eris, Haumea, Makemake. We were beginning to find other things in the Kuiper Belt. So astronomers were forced with a really difficult decision. Because at this point, we didn't actually have a definition of a planet. We really didn't have a really strong definition of what a planet is. So we were forced to continue studying and thinking and learning more about what is out there. And when we compare Pluto with the other dwarf planets, we find that Pluto actually has a lot in common with them. Right? So we'll bring up to scale all of the dwarf planets in a moment here, to compare them all together. Oh, and actually, that's a really, really great thing. Great question that just saw being asked in the chat by Teresa. So, why did it take us so long to find these other objects? Well, Pluto was a little bit of us getting lucky. These things are really hard to find when they're this far away. They're very faint and hard to see. So with Pluto, we kind of got lucky. Clyde Tombaugh kind of got lucky in finding it. Then in the early 2000s, our telescopes got strong enough to make it easier, and so we kept on finding more things. Now, why did it take us so long to find out how big Pluto was? That's a good question. We'll talk about that in just a moment as to why we thought Pluto was so much bigger. In short, Pluto looked a lot brighter than we expected it to be because it's made of kinds of ice. We'll talk about that in just a second. But we'll bring up the other dwarf planets for comparison. We got Eris and Pluto, which are very close in size. Actually, Pluto is a little bit bigger than Eris, just a little bit bigger, maybe like 10 or 20 miles bigger than Eris. A little bit smaller than Pluto is Haumea, a little bit smaller than Haumea is Makemake, and then a little bit smaller than that is Ceres. So astronomers had to get together and figure out what exactly is a planet, right? Do we name all these other things planets? Do we name Eris, Haumea, Makemake, Ceres as planets? Or do we rethink what a planet is? And in 2006, a group of astronomers, the International Astronomical Union, got together and they set out to make a definition for what a planet is. And they came up and agreed to 3 things. So what would make something a planet? The first thing you need to be a planet is you need to orbit the sun, which Pluto does just fine. So far, so good. Pluto also needs to be spherical, be a planet. Okay, fine. Pluto is spherical. So far, so good. The final thing the IAU came up with to be a planet is that you have to have cleared your neighborhood. What does that mean? You need to have cleared your neighborhood. Well, that means that you need to be the largest thing in your part of the solar system. So Pluto makes its orbit around the sun. To be a planet, it would have to clear out that orbit. It would need to be the only massive thing in that orbital path. When we look at the Earth or Mars or Jupiter or Saturn, they are without a doubt the most massive thing in their orbital path. In fact, if you take all of the stuff that lives in the same part of the solar system as the Earth is over 1 million times more massive than all of that. Pluto, if you do the same thing, Pluto is actually only, it actually makes up just a really, really small fraction of a percentage of the mass of stuff in its part of the solar system. So based on this definition, Pluto can no longer be considered a planet because it is not the only thing in its orbital path. So that was the decision that was made by the International Astronomical Union back in 2006. But why did we have to redefine a planet to begin with, right? Why does this matter? Why did we need to redefine what a planet is? Well, if we go back here a little bit, we had found these 4 dwarf planets, right? If we were going to consider Pluto to still be a planet, these other 4 objects would also have to be considered planets. Okay, fine. That's well and good. There's nothing wrong with having give us 13 planets. But then astronomers were left to think, if we have found 4 other things, what if there's more out there? And in fact, since then, we have found probably about between like 50 and 100 other objects that could be called planets if we didn't set this definition. So we were left with the decision, do we leave Pluto as a planet? Then we would have to include about 100 other things. Or do we group Pluto in with these other 100 or so objects and call them all dwarf planets? So that's where the decision was made. It was made because we had to draw the line somewhere. And Pluto just so happened to fall on the other side of it. Anything that orbits the sun, that is spherical, that hasn't cleared its neighborhood, can be considered a dwarf planet. Now, just because Pluto is called a dwarf planet now, doesn't mean it's changed. Pluto hasn't changed at all, really. As we found it, it's the same planet it's always been. The same dwarf planet it's always been. The only thing is we learned more about what else is out there. It forced us to reconsider what a planet is. It's a really important thing to remember, that when we do science, we are always learning more, and we're always open to look back and realize that we were wrong about something. But just because Pluto is a dwarf planet today doesn't mean it's not special, right? It's still a fascinating place. And in fact, back in 2015, this spacecraft here named New Horizons flew by Pluto. In July of 2015, New Horizons made a very, very close fly by Pluto. Now, it didn't only study Pluto, it also studied the other moons that Pluto has. Pluto has 5 moons, the largest of which is Charon. We'll talk about that one in just a little bit. So we're still learning more about Pluto. New Horizons flew by Pluto almost 5 years ago, and we're still learning more from what New Horizons taught us. And in fact, what's really cool about New Horizons, it took so long to get to Pluto that when it was launched back in early 2006, Pluto was still considered a planet. 6 months after it launched, Pluto had been reclassified, and by the time it got there, Pluto was called a dwarf planet. So New Horizons was launched to explore a planet and ended up exploring a dwarf planet. New Horizons, though, has continued to fly through space. It made a close fly by another object out in the Kuiper Belt a couple years ago, and is continuing to study space still to this day. Now, I want to talk about what makes Pluto so special. I mentioned before the show that Pluto is probably my favorite object in the solar system. Whether it's a planet or a dwarf planet, doesn't matter. It is still such a cool place. So when New Horizons was launched, we expected to find that Pluto was just a gray, boring, cold planet. We didn't expect Pluto to be interesting. But when it got there, we found out that Pluto was maybe the most interesting place in the solar system. The first thing, the most obvious feature about Pluto is this big white heart shape here. Which of course is Pluto letting us know that it still loves us, even though we reclassified it as a dwarf planet. But this big white heart is maybe the most interesting place in the solar system. We're going to take a closer look here. This left side of it is known as the Sputnik Planitia. And like the rest of Pluto, it's made up mostly of nitrogen ice. Really, really cold. Pluto is about minus 370 degrees Fahrenheit. It's made up of nitrogen ice. When we first looked at this area, we were really confused because we don't see any craters here. We don't see any craters in the Sputnik Planitia. We don't see any craters, which is surprising because the rest of Pluto is covered in craters. And we expect, under normal circumstances, for craters to be spread out pretty evenly across the surface of a place like Pluto. Looking at the rest of, we see a really big crater right here and here and here. So why does the Sputnik Planitia not have craters? Well, it means, because it doesn't have craters, it means that Pluto has some way of filling in those craters over time. So it has some way to like resurface or to repave this part of its surface. So there's some source of heat deep inside of Pluto that lets this happen. What's causing the heat? We don't really know. We really don't know what's causing that heat. Some astronomers think the inside of Pluto is radioactive, causing this heat to essentially slowly melt and reshape this area over time. We don't know though. Pluto is such a cool place because there's so much we don't know about it. We're still learning more about it every day. We also find some other features on Pluto that are kind of confusing, right? We find all these big cracks that cover the surface of Pluto. They cover the surface. We don't know why those are there. We don't know for sure. So there is so much more that we don't understand. I actually want to rewind a little bit here because I just saw a really question about whether or not Pluto has any water on it. It's a really, really good question. So Pluto does not have any liquid water on it. We think it might have liquid water inside of it, but it doesn't have liquid water on it. But we look at these tall mountains here on Pluto, and a lot of these are made of water ice, which is really, really cool. So it's really, really cool. So Pluto, again, is at its warmest minus 370 degrees Fahrenheit. It is so cold on Pluto. So thankfully, we don't need to send people to study Pluto. New Horizons didn't have any people in it. It was just a robot that we sent out into space. The robot doesn't care how cold Pluto is. It does its job just fine. But Pluto is not alone in its part of the solar system. It has moons. It has 5 moons, in fact. Its largest moon is named Charon, or Charon, depending on who you talk to. Charon's a very interesting moon because it is pretty big. It's only about half the size of Pluto itself. Some scientists actually think that the Charon here should be called its own dwarf planet because it's big enough. So maybe this Pluto and Charon system is a pair of dwarf planets orbiting each other. We don't know. So Charon might be considered a dwarf planet at some point in the future. But also when New Horizons saw Charon up close for the first time, it found all this weird reddish-brown stuff up. Weird reddish-brown looking dust. And this actually comes from Pluto's atmosphere. Pluto is not massive enough to hold onto its atmosphere. So that means some of the material from Pluto's atmosphere falls on to Charon. Then it interacts with sunlight and it turns into this reddish-brown color. Pretty cool. So Pluto is such an interesting place, right? It doesn't really matter that we downgraded it to being a dwarf planet. It doesn't really matter that we've done that because it's still a fascinating place, maybe the most interesting place in the solar system. And Pluto really is a great story at how science works. Right? Scientists are always open to the idea that we can be wrong and learn more. And Pluto is a great case. When it was found in 1930, we were really sure that it was a planet. But as we learn more about it and about the other things that are out there in the solar system, we were forced to rethink that idea. We were forced to be really good scientists and to rethink what exactly a planet is. Turns out that Pluto just didn't meet that criteria, which is okay. Pluto is still fascinating. It's still a wonderful place, and somewhere that we're learning more about every single day. So, to just recap a little bit for anyone who is just joining us over the past few minutes, Pluto is no longer called a planet because we made a new definition as to what a planet is. Pluto does not meet this third part of the definition. It has not cleared its neighborhood. To be a planet, you need to be the only big thing in your orbit, and Pluto has not done that. So Pluto today and for the foreseeable future is going to be considered a dwarf planet. So with that, with our, we talked a lot about Pluto so far. That does bring us kind of to the end of this part of our show. I do want to thank everyone once again for joining us today. I'm not going away though. I'll be hanging out here for a little bit longer to answer more of your questions. But I do want to thank everyone for joining me today. I'll be back here the same time at 1 o'clock next Thursday. We're talking about the structure of the universe next Thursday. We're also hosting a couple more live streams here on our Facebook page between now and then. This evening at 6 o'clock p.m., we are hosting trivia here aimed at adults. That's tonight at 6 o'clock. And then tomorrow morning at 11:30 a.m., we're going to be hosting trivia that is aimed more at kids and families. So we do hope to see you tuning in for the rest of our live streams. We are broadcasting something live every day, Monday to Friday. So please do tune in to the rest of our streams. But I will see you again next Thursday at 1 o'clock, where we'll be talking all about the structure of the universe. But for now, if you have any questions that you still have about Pluto or about any other place in the solar system, feel free to leave us a comment. I'll be hanging out for about another 10 or 15 minutes answering more of your questions. All right. Okay, so Tom wants to know, Tom wants to know, since no one has gone to Pluto, how do we know all that about Pluto? It's a really, really good question. So even though no humans have been there, we did send our good friend New Horizons to visit Pluto. So New Horizons was a robotic spacecraft without any people on board. So it was able to be sent out there. It had a lot of instruments, cameras, and other things that we use to study and learn more. So we can learn about Pluto without actually sending any people out there. So I've also seen a few questions so far during our show about people who still argue to consider Pluto as a planet, which is something that a lot of astronomers do think could happen. So the idea to reclassify Pluto as a planet comes down to some astronomers not agreeing with what we made that definition as. Those three things: to have cleared your orbit, clear your neighborhood, to be a sphere, and to orbit the sun. So a lot of astronomers have proposed other definitions for what makes something a planet. And under those definitions, Pluto could be called a planet once again. Now, in my opinion, and in the opinion of a majority of astronomers, those aren't the best definitions, because then we would end up not with 8 or 9 planets, but with over 100 planets. If we expanded that definition to include Pluto, it would also have to include the rest of the dwarf planets, like Ceres and Eris and Haumea and Makemake. It would also have to include other things that we found so far. We would have almost 100 planets right now if we made that definition bigger. So it really does come down to a decision between, do we want to keep the number of planets as a smaller group, as a smaller club, or do we want to make it really big? So astronomers voted and decided to keep it as a smaller club, which meant that Pluto had to be excluded from it. Which is really great, because if we renamed Pluto as a planet, there would be 100 other names of planets that you would have to remember in school, which sounds really hard. But now you've got to memorize 8 of them, which makes life a little bit easier. Okay. So I saw Lauren ask a really, really good question. That Pluto is a much more active world, much more kind of detailed, interesting world compared to other places like Eris. So could that make it a planet just because it's so interesting? And that's another argument that is out there, right? We see that Pluto is still geologically active. It's still resurfacing itself. So one of the ideas that has been put out by a group of astronomers is to consider whether or not a planet is still geologically active or is still active in its atmosphere, to name that as a planet. So that's one idea. But if we were to do that, we still haven't really studied Eris that closely, or Ceres that closely. So we could still learn more about those places that would make them just as interesting as Pluto. So for now, we're left with that definition with those 3 bullet points in it that excludes Pluto. Let's see. So Maria wants to know, when did we decide that Pluto was a dwarf planet? So that happened back in 2006. That happened in the summer of 2006. Pluto was reclassified as a dwarf planet. Now, I also saw someone ask a moment ago, how long would it take for humans to get to Pluto? It would take over 9 years to get to Pluto. Our good friend New Horizons here took 9 years to travel from the Earth to Pluto. It would take humans even longer than that, because we can't move as quickly. So it would take us at least 9 years to get to Pluto. It took New Horizons that long. It took humans at least 9 years to make it to Pluto. Now, to answer another question that I just saw scrolling by, New Horizons didn't actually land on Pluto. It just flew by. So it didn't land on Pluto or orbit Pluto. It just made a quick flyby and then continued on its way out into space. So it didn't land there, but it did help us learn a lot more during this very, very so how many dwarf planets are there in the solar system? Prasanna wants to know, how many dwarf planets are there in the solar system? Right now, there are 5. There are 5 dwarf planets in the solar system. There are other objects, though, that we could classify as dwarf planets in the future. So to decide whether something is a dwarf planet or not comes down to a vote from that same group that reclassified Pluto, the International Astronomical Union. So it really comes down to their vote. But today there are 5 dwarf planets. In the future, though, we'll probably have more, because we keep on finding more and more stuff. Let's see. So Dylan wants to know whether Pluto is hot or cold. It's a great question. So Pluto is really cold. It is minus 370 degrees Fahrenheit. It's really, really cold. At its warmest, 370 or minus 370. There are places that are even colder. The coldest parts of Pluto are like minus 500 degrees Fahrenheit. So Pluto is really, really cold. It's one of the coldest places in the solar system. Burrell wants to know, how long does it take Pluto to orbit the Sun? It takes over 200 years for Pluto to make one orbit around the Sun, which means that since we found Pluto, it hasn't actually finished orbit. So in the almost 100 years since we found Pluto, it hasn't actually completed an entire year quite yet. is really interesting to think about. Yeah, its year is about 248 years it takes Pluto to make one orbit around the sun. So yeah, it's a very, very long time. Jamie wants to know, did New Horizon take any samples of Pluto? So it unfortunately did not take any samples of Pluto because it did not land on the surface. It more just took pictures and analyzed Pluto kind of from a bigger distance away. It didn't actually take any samples. It was able to study more about it from a distance, but because it didn't land there, it wasn't able to actually take a sample. Let's see here. So there are so many great questions. There's so many great questions out there. I'm going to answer definitely a few more. Okay, so Nora wants to know, what is Pluto made of? So Pluto is made up of the surface anyway is mostly ice. So about 98% nitrogen ice. Now nitrogen is a gas here on the Earth naturally, but it cools down. When it cools down, like it does on Pluto, it can actually turn into a solid. So it's made up of mostly nitrogen ice, which is really, really cool. That nitrogen ice is kind of soft. It's almost got a texture like ice cream, almost, like really hard ice cream. I wouldn't recommend eating it because it's very cold, but nonetheless, it would have that kind of like ice creamy texture. Some of Pluto though is water ice. Some of it is methane ice, which is really cool. It's such a different place than the Earth. Let's see. So Shruti wants to know, is there a specific size to be a planet? So yes and no. There isn't like a really well-defined like if you're larger than 500 miles across, you can be considered a planet. But to be a planet, you need to be big enough to be a sphere, like Pluto is. So Pluto meets that criteria. So to be a planet, you just need to be big enough to have become a sphere. So the more massive something is, once it reaches a certain point, it can form into a sphere because it has more gravity. So that is really the kind of the size limit, and it has to be a sphere. If it's too small, it can't be a sphere. So that's so that's where we get size into our definition. So how long is a day on Pluto? How long is a day on Pluto? I'm seeing that question quite a few times. So if I remember correctly, a day on Pluto is about 6.5 Earth days, if I'm not mistaken. So it's just about 6.5 Earth days for Pluto to make one rotation. Sai wants to know, is New Horizons still in space? So yeah, New Horizons is still in space. It's still traveling out into the solar system. That's a great question. It's still flying away out further into the Kuiper Belt, and is going to keep on studying space for as long as it stays active. But it's going to keep on traveling forever. There's nothing to stop it. It's going to keep on going, which is really, really cool. Okay. So I'm seeing questions about how big about how big Pluto is. So Pluto is about 1/6 the diameter of our very own planet Earth. That means that it's about 1,500 miles across. So it's about 1,500 miles across, which is smaller than the United States, smaller than Australia even. let's definitely have time for a few more questions. So Uma wants to know, what is the larger objects that are in Pluto's orbit that make it not a planet? So it's not necessarily just one object, it's really that big collection of material in the Kuiper belt. So because that Kuiper belt still exists and there's so much stuff in it, that's really what makes Pluto not able to be a planet based on that definition. But the other dwarf planets, Eris, for example, live in the same part of the solar system as Pluto, and they're about the same size as Pluto. So for us to say a planet has cleared its orbit, it really needs to be the single dominant biggest body, and there has to be almost nothing else left in its orbital path. And Pluto just unfortunately hasn't done that yet, and probably never will. I've got a question about whether or not Pluto is going away from the sun. That's a really, really great question. So Pluto isn't really going away from the sun. Pluto is in an orbit around the sun, just like the Earth is in an orbit around the sun. So Pluto is going to keep on going around and around its orbit around the sun, just like the Earth does, just like the rest of the planets do. It's not really moving away from the sun, at least not that we are aware of. So I've got a question about what is my opinion on Pluto, whether it should be a planet or not. So in my opinion, Pluto should be a dwarf planet. It has a lot more in common with the other dwarf planets than it does with the rest of the planets, and we've got to make a cutoff somewhere. We've got to make a cutoff somewhere. Otherwise, our kids in school have to learn the names of 100 planets, right? So they're, in my opinion, it should be a dwarf planet. But that doesn't change the fact that Pluto is still a really, really cool place, right? Just because we call it a dwarf planet now doesn't mean it's not a fascinating world that we love to learn and explore about. But in my opinion, it's a dwarf planet, and it probably always will be. So a really, really good question. Will scientists ever make a spacesuit that will be able to travel to Pluto? Maybe. I don't know. In the future, it's definitely possible. Even though it's really cold, we're getting better at making spacesuits. So someday, in hundreds of years from now, humans could very well build a spacesuit that can let us walk around on Pluto. Which would be a really, really cool thing to do, but probably not anytime soon, unfortunately. So Paul wants to know, what is bigger, our moon or Pluto? It turns out that our moon is actually larger than Pluto. So our moon is larger than Pluto. I'm seeing so many really, really good questions. So Vicky wants to know, how many days did New Horizons travel for? So to get to Pluto, it traveled for about 9 years. So it traveled for 9 years to make it to Pluto, which is that's a long time. 9 years. So Becky wants to know, this is a really, really great question. So why can't Pluto take over its orbit? Why can't it clear out its neighborhood? That's a really good question. It comes down to the fact that Pluto just isn't big enough, right? If Pluto were way more massive, like if Pluto were as massive as the Earth or as massive as Jupiter, it would be able to clear out its orbit because it would have enough gravity to either pull the rest of that material into it or to push it all away. So Pluto isn't able to clear out its orbit, clear its neighborhood, because it is just not big enough. There's not enough mass there to allow it to happen. Mercury, for example, is a smaller planet. It's the smallest planet that we have. It's not very big, but it didn't have much stuff in its orbit to begin with to clear out. So Mercury had it easier than Pluto as well. Pluto has a lot more stuff to clear out, so it needs to be a lot bigger to do it. And Pluto isn't really getting any bigger. I did see another question asking, and this is another really, really great question, asking if Pluto is resurfacing itself, is it going to get bigger over time? So it's not going to be getting bigger over time because it's really resurfacing itself with itself. So Pluto isn't really gaining any new material. It's just kind of moving around what it already has to resurface that area. So Pluto isn't really going to be getting any bigger, which means that it probably won't ever clear out its orbit. Just doesn't have a way to get massive enough. Because when it resurfaces itself, it's just kind of reusing the stuff, the stuff that it already has. Just kind of moving it around in a different way. So Sarah wants to know, how old is Pluto? So Pluto, we think, is about the same age as the rest of the planets in the solar system. So about 4.5 billion years old. So it's about 4.5 billion years old. At least that's our best idea right now, right? We could learn more about Pluto in the future that would let us know that maybe Pluto's younger than that. But for now, we think it's about 4.5 billion years old. Okay. Any good question? All right. So Stephanie wants to know, how cold is Pluto's moon Charon? So Charon is actually a little bit colder than Pluto is. Charon is about minus 450 degrees. Charon doesn't have an atmosphere, so it isn't able to trap heat on its surface. Pluto has a very, very thin atmosphere, trap a little bit of heat on its surface. And so yeah, Pluto is about 4.5 billion years old. It's very, very, very old. All right, so I think I have time for maybe just one more question. One more question. So what is the name of that belt that Pluto is a part of? So that belt of material that Pluto is a part of is known as the Kuiper belt. Called the Kuiper belt. It's really just a big group of smaller pieces of like ice and rock, which Pluto lives in. So it lives inside of the Kuiper belt. So with that, I have been going for almost an hour now. So this means I am all out of time for our show here this afternoon. I do want to thank you all so much, though, for joining us today, talking all about Pluto. I hope we all learned a lot and had some fun along the way. I'll be back here, though, next Thursday at 1 o'clock, talking all about the structure of the universe. It's going to be a really, really great show. So hope to see you all back here next Thursday at 1 o'clock. And remember, right here on our Facebook page, Liberty Science Center is going to be running trivia tonight at 6 o'clock, which is going to be aimed toward adults. We do hope to see many of you joining us for our trivia here tonight at 6 o'clock p.m. But with all of that, thank you all so much once again for joining us today for our another edition of Planetarium Online. Have a wonderful rest of your afternoon and have a fantastic rest of your day. Thank you all so much.